Question 2. Figure 2.1 shows an athlete crossing the finishing line in a race. As she crosses the finishing line, her speed is 10 meters per second, and this is initial speed, symbolized by U, and she slows down to a speed which is 4 meters per second, represents the final speed, symbolized by V. In part A, the mass of the athlete is 71 kilogram, so this is the symbol by the letter M. And to calculate the impulse applied to her as she slows down, for the impulse here, which is equal to the change in momentum. Okay, the momentum, as you know, it's the product of mass and velocity. So the impulse here equals to the mass, symbolized by m, as we said before, times the change in velocity, which is v minus u, equal to the 71 and times the 10, which is final, minus 4. So it gives us finally 430, and the unit here, which is Newton seconds. This question has 3 marks. 1 mark for showing what is the link between the impulse and the change in momentum, and the correct substitution, and finally the correct answer with the unit. In part B, to define impulse in terms of force and time. The impulse equals to the product of force times the time taken here. So we get 1 mark. It's an easy peasy question, straightforward. In double I, the athlete takes 1.2 seconds, which is the time taken, and to slow down from a speed 10 meters per second, initial speed is u, and to a speed which is finally is 4 meters per second. The examiner is directly asking for calculating the average resultant force F applied to the athlete as she slows down. Okay, we can use the previous from BI, the impulse equals to the force times time, so the force equals to the impulse divided by the time taken. So from where we can get the impulse, if you remember, go back, stop the video, go back a little bit, few seconds. The impulse was calculated in part A, it was 430. And if you remember that we calculate the mass times the change in velocity from the impulse, 71 times the 10 minus 4, it gives us 430 for impulse divided by the time taken. The time taken is already given here is 1.2 seconds. Okay, finally, using the calculator, it gives us 360, and the correct unit is Newton. This question has 2 marks, 1 mark for showing the formula with the correct substitution, and the correct unit with the final answer. For part C, to calculate the force required to give a mass of 71 kilogram, the same mass used in the previous section, and acceleration, which is 6.4 meters per second squared. And here the only formula or linked equation, force and mass and acceleration, Newton's second law of motion, which is F equals m times a. So the mass, which is 71, times the acceleration is 6.4. So the correct answer finally is 450 Newton. Okay, the section has 2 marks. 1 mark for showing the Newton's second law of motion and with the correct substitution, and finally the correct answer with the unit.